Good morning. Today we are going to solve exercise 327 from the book Sadiku Electrical Circuit Fundamentals. In this exercise, we know that it is in terms of conductance, not of his existence, as in his previous ones. I recommend you watch the video 315 where I explain how to work better on this type of exercises. We know that they are Siemens and they are not Nordic. Well, the first thing I advise to solve this type of exercises is to do a visual analysis of the direction of the currents, looking at the voltage sources, the current sources, the direction in which it is pointing. Let's observe that this here is node B1. It is a point in common, and this one here is node B3, which is another point in common. Starting from that, we have to look at the currents that enter and leave those points. That thing we have to see is that this is a dependent current source that depends on the variable I0 and the current XL that circulates here. Okay, then, in the Larida node, I'm going to look at the sources that are among those that come out. The current house I2 that was there that enters here and a current comes out in this direction. We assume that. Then, because here as it has a resistance, I say that a tension is 0 and a tension is greater than 0, assuming that. Now, this 42 enters this entire point. One part comes from here, the other comes from here, which is this fountain with this pendant. I say that the other comes from here. That connects that comes here. Well, it reaches this point and one part comes this way, and I say that the other comes through this source. When we reach this point, we observe that a source of 4 amperes falls. It enters here and joins with this. So, I say that another current comes through here and this resistance or this conductance is missing. So we see that I am doing a visual analysis. I say that 2 amperes is less than 4. Here enter 2, and here enter 4. I guess the current comes from here. It doesn't matter if I'm wrong, because at the end of the voltages it's going to give us positive or negative, and that tells us where the currents are actually going. So, in node B1, that is, this entire point, look at the currents that enter. Maybe the ones that enter will be 2 amperes and the current that comes from here. Let's name it once and for all. I'm going to call this one N1. I'm going to call it N2. This is the I3. This is the I4. This is the I. Everything here enters the, between the amperes, enters the I5, and what comes out would be the current I1. The current I2 comes out, the pending current source comes out, and you breathe. Okay. Well, then, 2 amperes plus the 45. The 45, as I say, what goes this point? This point, this is all B3 would be P3 minus B1 which multiplies the 400 meters. Let's remember that since we are working remotely, this is common. If it is still not clear, please review video 310, 315 and 316. This is going to be equal to the current I1 it would be 2, or well, it would be P1L. Two. Why does V1 occur? That if it were, this, since it is conductance, is the voltage in this resistance times the conductance, it would be 2 times B1, plus the current N2, which is this, the residence is A Siemens, which multiplies by 1 minus B2, from 1 minus B2, plus La files. The source with this slope that would be 3 times in 0, but in 0 is what comes here. Here it is 4 times B2. 4B2. Okay, I start to work with that. I have here 2 plus 4B3, 4B1. It is equal to, I have 2B1 plus, this would be P1 minus P2. P2 plus 3 12 B. Okay, it applied to, right? I take everything that has a variable on one side, like minus 4 P3, it's going to be equal to 2. It's going to be equation number 1. I'm going to place it here to do more steps, and it would be 7B1, it's CB2 minus 4 3, it's equal to 2. First thing, I'm going to delete this. And here I'm going to do B2. In the new B2. In the new B2 I get that what comes in here is the current I2, and what comes out is I0 plus I3. 2. I2 is going to be equal to I0. So, equal to I0 plus I3. Let's remember that from here to there, it is what enters there that leaves the node. 2I2 would be B1. L left V. Coming this way would be 4 times 2 more. What coming this way would be 1 time La files. So hoping that would be B1 minus B2. Hi, 4B2. 4B2 plus B2 minus B3. So, I reorganize, I leave everything on one side just like that, which I'm going to keep here. So, you can verify it, minus B1 plus 6B2 3 4. Okay. So, in node B3, let's go out, that would be all this that is here. We look at what comes in, as well as what comes out. What comes in here on this side would be the 3 and 0, plus between the I3 plus the 4 amperes. It would only be equal to what comes out, that the 45 is lost, plus the 1 who adds the most to the document and 4. Okay, so 3 and 0. Well, we already said it was 3 times, the 40 and 0. The 40 and 0 is 4 times B2. 4 times B2. Bad 43. The 43 B domino P3 that multiplies to 1, which is the conductance, the ignition, plus the 4 amperes. L. So, anyway, parentheses, current 5 has it here, which would be D3, P 1 4. More. The 44 that would be what comes here would be this 2 times of 3, well, operating. I have here 12. B2 plus B2 plus B3. I'm opening the parenthesis. 1 I multiplied to each one, plus 4. One of the constants. The value of the current source is equal. It is 4 amperes. 4B3 minus 4B1 plus 2 times 20. Okay. If I organize, I put on one side the same as the variables on the other side, the constants, so the issue remains less for me. 4P1 13P2 plus 7B3 is going to equal 4. Unico as in 3, I'm going to put here minus 4B1 minus 13B2 plus 7B3 equals 4. It would be my equation. Seven 11 minus 4. 7 space 11 space minus 4, period and com. To move on to another quote. Minus 1, 6, minus. Now, for matrix B I have to be on the other side equal, 2 0 and 4. 2 semicolons. I check that I have the voltage values 0.625, 0.3750, and 1.62. These are, we criticize. Okay. Here I tell you that B1, as you are asking, 0.6 125 volts, or also by inheritance 625 millivolts, running at 1, 2, 3, 3, put in the purchase. B2 0, 375 volts is equal to 375 milliwatts. And B3 1.625. Ready? So, see you in the next access.